And they will be basically, all over the place. In some, we know the annuity present value, in others the annuity future value. Some are annuities due, some are ordinary annuities. In some, we need to find the annuity payment, in others the interest rate, and then yet in others the number of annuity payments. So everything will be kind of completely mixed up. Well, messed up too. So let's start with this first example. You won a lottery, $12 million. You have two choices. First, you take $7,042,000 today and nothing else in the future. Just one single lump sum payment to you. The second choice you have is you take 26 annual payments of $461,538 each. Where did this strange number come from? That's a very simple division of $12 million by 26. The question is, what is the implied interest rate? I would say for problems like this, kind of don't rush into trying to use a calculator and solving for something. I would say first answer these 4 questions. First, probably the most important one. Are we working with the present value or the future value of an annuity? Which one is known? The second one, is it an ordinary annuity or an annuity due? Then what are we asked to solve for? And once you figure out what you need to solve for, then you should be able to then you need to figure out what it is that you would need to input in your calculator. So there are always 3 numbers that are given and the 4th one that you need to solve for. So is it an annuity present value or an annuity future value problem? The money you want, $12 million, one way to collect it is to receive 1/26 of that, of $12 million every year for the next 26 years, right? So $12 million that you won is basically the sum of the annual installments in today's dollars. So this is the present value of an annuity. So you kind of really need to understand from the wording whether this large number, which is your annuity value, is the present value or the future value. I guess here the hint is you want the money today. So anything that's today is the present value. Okay, so we answered the first question. We are working with the present value of an annuity. The second question is it an ordinary annuity or an annuity due? How can we tell? An ordinary annuity is when the annuity payments, the numbers which are repeating, are occurring at the end of each time period. For example, at the end of each year. And an annuity due would be when the payments occur at the beginning of each year. So they're due immediately. What do we have here? When would the annual installments be paid? Actually, it doesn't really say. What should we assume? The default is at the end of each year. That's always the default in finance classes. And that's the ordinary case. And that's where the name ordinary annuity comes from. So we are working with the present value of an ordinary annuity. All payments will occur at the end of each year. So to collect your first installment, you would need to wait 1 year from today. That's what it means. Then the third question I put here is, what do we need to solve for? Well, the question was about the implied interest rate, so it's pretty straightforward. We need to solve for interest rate. So that's IY in the financial calculator, if that's what you will use to calculate the answer. In the formula, that's R, which stands for rate of interest. And once you figured out what you need to solve for, then the last question I would recommend you answer to yourself is, okay, which numbers do I need to input in the calculator? So we already know that we are given the present value of an annuity. That's one. $7,042,000. Then the other two will be N, that's 26 future annual installments if you choose the second option. And the third number that is given is the cash flow amount, the annuity payment, or PMT in the financial calculator. That's the amount of each annual installment for the next 26 years. $461,538. Okay, now the easiest would be probably using the financial calculator. You input your present value, N, and PMT, and you're computing IY. So let's do that in the financial calculator. So here's the financial calculator. Turn it on. I always recommend to start by clearing everything, because even if you used your calculator last week, last time, it will still store some values unless you already cleared it. So do a full reset just to be, absolutely sure nothing is stored. Second, plus minus, enter. The only problem is if you increase decimal places, then now that drops down to 2, which is the default number. So maybe we should increase the decimal places. How would you do that? That's actually always a good idea, especially in multi-step problems. Here it's actually okay, and my answer is rounded, as you can see, to 2 decimal places, but let's say you need more than 2 decimal places in your answer. Then that's the first thing you would do in the calculator. How do we increase decimal places? Second, decimal place on the bottom. The default decimals is 2. You want to change it, let's say, to 6. Press 6, enter. You're done. Now you can turn the calculator off and back on. It's going to be calculating everything from now on until you reset it to 6 decimal places. So now let's solve this problem. 7,042,000, make it negative. That's our annuity present value. And you're indifferent between collecting this one lump sum amount today or instead collecting 26 annual payments in the amount $461,538. So let's input that like second option values. So that's equivalent to collecting 26. So you put 26N. The payment amount for each installment would be 461,538. You leave the sign as is, you don't change it to negative. So kind of the way to remember it is everything that's today is one sign, everything that's in the future is with the opposite sign. So we entered our present value with the minus sign, which means we should leave the PMT with the positive sign. So I input the value and then I press PMT. Now it's stored as the annuity payment. Okay, so we put in PV, N, and PMT, and now we just press compute IY. 4.431201. If the answer needs to be rounded to 2 decimal places, then that's 4.43% per year, the annual interest rate. Now let's look at the second problem. You want to save up $60,000 for your graduate degree that you plan to start in 4 years. You keep all your money in an account that offers an 8% rate per year with the interest earned monthly. If you plan to set aside fixed amounts of money at the beginning of each month, what will your monthly deposit be? So once again, the same 4 questions. Are we working with the present value or the future value of an annuity? Is it an ordinary annuity or an annuity due? What do we need to solve for, and which numbers are given? Technically, you can add a couple more questions at the beginning of that questions list. For example, I would say the very first question should be, are we working with a single cash flow or multiple cash flows? The way you know that this problem is not about a single cash flow, even though it looks like there's only one, but multiple cash flows, is again from the wording. You will be setting aside amounts of money at the beginning of each month. So it's something repeating monthly. There are many cash flows. So it's not like a chapter 5 type problem with one cash flow. It's chapter 6 type problem with multiple cash flows. Then another extra question you could ask yourself is, now that we know it's multiple cash flows, are they different amounts or the same amounts? Well, we will be setting aside fixed amounts of money at the beginning of each month. So every month it will be the same amount of money that we will be setting aside. So it's the same cash flow, repeating again and again. What do we call that? That's an annuity. Okay, now let's go, look at this list. Are we working with the present value or with the future value of an annuity? Which one is known? So if we want to save up $60,000 for our graduate degree in 4 years, then $60,000 is in the future, right? That's our goal for the future. That's what we want to have at the end of all of our monthly deposits. So this is, how you can understand that it's the future value that is known. So $60,000 is the future value of many, many, many equal amount deposits. And that's what the question is asking us to compute. So we are working with the future value of an annuity. We've just answered the first question. Second question, is it an ordinary annuity or an annuity due? So this refers to the timing of the repeating cash flows. When do they take place? Do they take place at the end of each time period or at the beginning of each time period? We know that we will be setting aside fixed amounts of money at the beginning of each month. The word beginning is the key word for annuity due. So we are working with the future value of an annuity due. And then the last two questions are, what is it that we need to solve for? For example, in the financial calculator, what are we going to be computing? And then the question after that is asking, what is given? And again, with annuities, 3 numbers are given. The fourth one is something that we need to compute. So what do we need to solve for? We need to solve for the amount of monthly deposit. That's the annuity payment. PMT in the financial calculator, or in the formula, that's capital C. Which 3 numbers are given? We already know that we are given the future value, and 2 more are how many deposits and the interest rate per time period. So there's a trick in this problem. Everything will be monthly, right? We are going to be making monthly deposits. As soon as you realize what the frequency is of your annuity payments, everything that you enter in the calculator should reflect that frequency. So for example, for your N, the number of deposits, you need to put how many monthly deposits you will have. Because in our problem, we will be making deposits over 4 years, you should put not 4, but 4 times 12 equals 48 for your number of deposits. So our N will be 48. And for the interest rate, we cannot use the 8% annual rate for IY. We need to divide it by 12 to get the monthly rate. which is 0.66667% per month. That's not in decimals, that's in percent. Okay, because it's an annuity due, the first thing we need to do in the financial calculator is tell it that we're going to be doing the calculations for an annuity due. So we say set the calculator to the annuity due mode or the begin mode. Okay, let's do that together. Financial calculator, let's clear everything. Let's increase the decimal places. Let's do 4 decimal places. Second decimal place, 4, enter. Off, back on. Let's start. How do we set the calculator to the annuity due mode or so-called begin mode? You press these 4 buttons. You press second, then you press PMT, then you press second again, and you press enter. And now if you turn the calculator off and back on, first it still remembers that you set it to 4 decimal places, and the second thing you may notice is the small letters BGN on the display, which stands for begin. We are now in the begin mode. And now let's enter the 3 numbers which are given and compute PMT. So we are given the future value of an annuity due. So you just put 60,000, change the sign to negative, and press the FV button. We have a total of 48 deposits that we would need to make in order to reach this $60,000 goal in our bank account. So you press 48N, and the last thing is the monthly interest rate. Remember, everything should be monthly in our calculations. The monthly rate is 0.66667. So technically it's a bunch of sixes. You can just keep pressing 66 multiple times, but I round it like this. It's a little bit random, I guess. After entering the monthly rate, you press the IY button. And finally, you press compute. What was it that we are computing? Payment. Compute payment. $1,057 and approximately 72 cents, right? If you round to cents. Next example. You have just bought a new flat screen TV that cost $4,000. You fully financed the purchase, which means you took a loan for the full amount, $4,000. You didn't pay anything out of your pocket. The loan agreement requires you to make annual payments of $750.54 at 5% interest, with the first one due immediately. How many loan payments will you have to make until the TV loan is paid off? Again, I'm asking you to ask yourself the same 4 questions as in my previous examples. The first question is, do we know the present value or the future value of an annuity? $4,000, the loan amount, is the present value of an annuity of loan payments. You can almost remember it as a rule. Any loan is the present value of loan payments, right? So $4,000 is the PV. Then the second question I have on my next slide is, are we working with an ordinary annuity or annuity due? We know that the first future loan payment will be due immediately. So all loan payments will be made at the beginning of each month, right? Once a month. Once a year. They are 1 year apart from each other. And if the first one is immediate, then that right away should tell you that we are working with an annuity due. Then what is it that we need to solve for? how many loan payments? Clearly that's N in the financial calculator or T in the loan formula. And which numbers are we going to enter in the calculator? The three that are given. 4,000 will be our PV, 750.54 is PMT, and 5 is going to be our IY, the annual interest rate. So we are working with the present value of an annuity due. We need to solve for the number of payments, which is N in the financial calculator, and the numbers that we are going to enter are PV what is $4,000, IY is 5, and PMT is 750.54. From my experience, a lot of students somehow tend to solve these kind of problems where it's asking you for the number of payments wrong. I see that a lot. So the wrong way would be kind of doing it the simplest way that sort of comes to your mind. You take the loan amount, 4,000, and divide it by annual loan payment, 750.54. That gives 5.33 years. While this is intuitively the right way to look at this problem, in finance, this is a wrong calculation. The reason it's wrong is because you're completely ignoring the so-called time value of money, the whole, interest rate that the lender charges you. It's not reflected here at all. And so the correct way of doing it is, first, because it's an annuity due, you press these 4 keys to set your calculator to the annuity due mode. Second payment, second enter. Let's do that. Financial calculator, let's clear everything. Second plus minus enter. To set to the annuity due mode, you press these 4 buttons. Second, PMT, second, enter. Now the display shows BGN, begin mode. And enter the 3 numbers which are given. $4,000 is your loan amount, which is always the present value of all loan payments that will follow in the future. So you want to change your sign to negative and then save it as PV. Then the interest rate is 5%, 5 IY, that's per year, and the annual loan payment will be $750.54. So you put 750.54. You leave this sign as positive because you already changed the present value to a negative one. By the way, either present value is negative and payment positive, or the other way around. So press PMT, compute N. 6 exactly. 6 payments. The first one due immediately and 5 more in the future. 6 payments total, 6 loan payments total. And you will fully pay off your loan balance. There will be nothing left for you to pay to the lender. So if you did it the wrong way, you will be off by, quite a lot. If you did it the right way, you will get 6 years.